Hello everyone. In this video I am going to demonstrate how to modulate RS-232 signal with a 48 kHz signal. So as you can see, this is my setup. In my setup I am using Arduino Uno and I am sending an alphabet R from the Arduino Uno. So this alphabet R from the Arduino Uno is fed to the optocoupler. So as you can see, this is the optocoupler here. So you can see here this LED is flashing and the data is from the Arduino Uno, the data is coming here to this optocoupler. From the output of this optocoupler, as we know, there is a transistor at the output of this optocoupler, MCT2E. So from the collector of this transistor, I am getting the same output with a higher voltage. Here you can see this is just an optical isolation of the Arduino Uno from the modulating circuit. So as you can see, this is the modulating signal. This signal is the output signal. This is the modulating signal. So this modulating signal is fed to 555 timer IC. As you can see here, this is the 555 timer IC setup. So the modulating signal is fed to pin number 4 of the 555 timer IC. So as you can see here, in the pin number 4, because too many cables are here. So as you can see here, this yellow wire, just a minute. Yes, so as you can see, this yellow wire is the modulating signal and it is connected to pin number 4 of 555 timer IC. You can see this yellow wire, this is the wire carrying the RS-232 data after the optical isolator. So from here you can see this yellow wire is the data carrying the optocoupler output. So this output is fed to pin number 4 of the Arduino Uno here. And this is an astable multivibrator mode 555 timer configuration. So it is just a minute. Yeah. So it is designed to generate a frequency of 48 kHz. So whenever we are feeding this modulating signal, the output is an amplitude shift keying. It is an ASK signal. So this is an ASK signal. At the output. The output comes at the pin number 3. So from the pin number 3, this is the final modulated signal. So let us see the final modulated signal in the oscilloscope. So as you can see, this is the oscilloscope I am using. This is a Handtech make oscilloscope. You can see this is Handtech oscilloscope. This is the make. This is 6022BE. So this is the oscilloscope I am using for this experiment. So the output we can show in the diagram here. As you can see, let me show it properly. Give me some time. Yes. So as you can see here, so let me stop the sampling because it will disturb the data. So as you can see here, this is the modulated signal. After modulation, this is the output coming at pin number 3 of 555 timer IC. You can see this is the signal coming at the pin number 3 of 555 timer IC. Here you can see this is the pulse. This is the pulse coming from the optical isolator, and when it is modulated, you can see 48 kHz signal is punched inside. You can see inside is the 48 kHz signal. So this is the modulated signal. You can see this is the modulated signal. So the modulated signal contains the real data. So the modulated signal, since it is having a 48 kHz signal embedded in it, we need to remove the 48 kHz signal using an envelope detector. So let me show you the envelope detector. So as you can see here, this is my envelope detector. I am using a Schottky rectifier as the diode, and this is my 0.01 microfarad capacitor, and this is a 100K resistor. This resistor is a 100K resistor. You can see this is a 100K resistor. So the output of this, so from this capacitor, the output is taken and it is monitored in the oscilloscope. So let me show you the output. So as you can see here, after the demodulation, this is the output. So you can see this is the output waveform. So this is the full view of the data. You can see this is the output waveform. So as we can see in the output waveform, we can see still some 48 kHz signals are there. So this is creating a problem while decoding the signal. You can see there are high frequency components inside. You can see, so these components are creating problems when I am decoding this signal. So in the next video, I am going to enhance this circuit further and I am going to remove these high frequency components. So once we can remove these high frequency components, we can demodulate. This signal is completely demodulated and we can analyze this signal with another Arduino Uno, or we can analyze this signal with a RS-232 serial port. So like this we can transmit serial data from one place to another using a modulation technique. Even though here we can see some high frequency signals are present, but already demodulation is done. You can see here there is no component. This is a clean area. Only at the top there is a high frequency signal. So this I will remove in the next video. I will design a suitable circuit and upload the next video. Till then, watch the next video. Thanks a lot. Thanks for watching.